In last class, we have seen how to draw 132 kV and 220 kV steel towers. In this class, we are going to learn easy method how to draw 3-phase 11 kV pole with its all accessories and stay wire, as well as how to draw the strut to support the pole. Let us see one by one in details. To transmit from receiving station nearby outskirts of our thickly populated areas, that is a substation, maybe 33 kV by 11 kV substation, to our nearby DTRs, who generally erected with HT lines. In HT system, the overhead pole consists of cross arms, clamps, insulators, conductors, anti-climbing devices, danger plates, stay sets, guardings, etc. already we have discussed in power system. In drawing point of view, how to draw 11 kV pole with required essential parts with given dimensions, dear students. PSCC poles 9.1 meters, rail poles, sometimes we can use the steel poles also for erecting the line. Let us take one 3-phase 11 kV line pole. Mainly the pole, so 9.1 meter pole. So here you can take one given dimension 9.1 pole, so thickness, so draw the one line here, it's a 9.1 height. Then this is a, let us assume this is a PSCC poles. The pole may be consist of cross arm. The cross arm may be flat, it may be V cross arm. Generally, the V cross arm are used under running in intermediate poles, whereas the flat cross arm generally you can observe. So this type of the cross arms you can see, this type of the cross arms you can observe under intermediate poles, whereas at the end you can observe this type of the poles. So this type of the poles you can observe with the stain insulator, disc insulators. At end you can use this type of the insulators, at corner we can use. So here I can use these 3 wires with help of the disc insulators. This is the flat cross arm, whereas in case of V cross arm case I can use the pin type insulators. So here I can use the cross arm is a V shape. Okay, so these are the 2 types of the poles present in our 11 kV line. Now let us assume this is a intermediate pole which consists of, so cross arm is the standard dimensions, V shape cross arm, and you can see this is one V shape cross arm, and the center there is a center bracket on which, so we are going to provide pin type insulators. Pin type insulator. Here I can this I can use pin type insulators. Pin type insulators. Here there is a clamp bracket is provided to hold the top insulators, and here the clamps are provided here to hold the cross arms. Now after that, the pole may be consist of some danger plate that is equal to 11 kV voltage. So danger plate, and sometimes we can use some anti-climbing mesh, that is so that's barbed wire is provided here to avoid the climbing of unauthorized persons. And sometimes we can use some stay sets also. As per IE rules, we can use every fifth pole we are going to provide stay set, or end pole at angle. So we are going to use this guy insulators, or if it is not possible to provide this guy insulators, this is a stay, then we can use a strut. Strut is some part of a pole, so it is supporting in this way. And so these are the normal tower. So these are conductors, R phase, Y phase, B phase conductors, RYB conductors. Dear students, these are the drawing you are going to draw with help of the drafter with clean. Okay, so this is one good example. Already you have studied overhead poles. What are the different accessories consist in overhead lines in power system. Okay, in drawing point of view, just you draw this single, take the 9.1 the meters height, take the standard V shape cross arms and place clamps. This is a clamp and this is a bracket, and you are going to V shape cross arm, and this is in pin insulators, this is a dangerous plate, this is a anti-climbing mesh, this is a stay, and this is a strut. So we cannot use at a time both, we can use only at stay or strut. Okay, so you can draw this on your drawing sheet. So now another small topic, that is a stay wires. What is the need of the stay wires? Let us assume this is a line 11 kV line 1 kilometer. The span of nearly 100 meters pole to pole. So gap, the span. So it is how many? Nearly 10 poles. You can observe that this pole 1, pole 2, pole 3 up to this one, this is under a running condition. Now initially you can observe it is connected to the, for example, there is a DTR, it is connected to the jumpers, connected here, and these lines are going towards this direction. So what will happen? So the end of these two poles, generally with help of the cross arms, flat cross arms with disc insulators, strain insulators. This one with the strain insulators, and this last end one is the strain insulators. Whereas this running, so we are going to provide simple, so V cross arm. So this is a under running condition, but at this is end we are going to use a strain insulators. Wherever you are going to use strain insulators, there is a possible to some forces may be occurred on the pole. Some of these poles in a line experience one side pull or force due to uneven line forces. Generally, the intermediate poles experience pull on either sides. You can see here, for example, take this pole. So whatever the force is applied here, same force this direction. Experience pole on either side equally for equal span lengths, but the poles on the end poles here or you can see the corner poles is uneven forces developed due to this forces. What will happen? Here the force only this direction, but there is no force here. This is the end pole. At the same time, the force is moving this direction. There is no force here. Hence, there is a unequal equilibrium takes place on the pole. It is to be avoided and very dangerous during the heavy gale and wind. Hence, we require to additional equipment to provide the poles for neutralization of these forces. Such arrangement are the pole stays or pole stay wire. Okay, dear students. So don't worry. So here what is happened here? You can once again you observe it. So the pole, this is the 1, this is the 2, this is the 3. These are the intermediate poles. Whereas this is the pole A and pole B or the end poles. 1, 2, 3 poles are subjected to the pull either this direction, right or left direction is equal for the equal span. But whereas the pole A and pole B, if you are observed, the pole A here there is a right side pull due to this line, but there is no pull towards the left side. Hence, there is a unequal forces may be subjected to this pole. And at the same time B pole, so there is a pull towards the left side, there is no pull on the right side. Hence, there is a unequal forces in the pole. These poles may be fall at any time due to the some winds. Hence, we require to make an arrangement, avoid this neutralization force with help of the some devices. Those devices are known as the stay wires. These stay wires are as per Indian electricity rule, every fifth pole should be stayed, and at the end of the poles we have to provide the stay sets, and at the angle also we are required to provide. For example, you can take this as a one line, and then the pole 1, pole 2, so pole 3, pole 4, pole 5, 6, 7, 8, 9, 10 poles. Here the starting poles we require the one stay sets anyway, and end poles we require the one stay sets. At the same time, the pole which is at the third corner we require the one pole sets towards the stay sets this direction, at stay sets this direction. 2 sets is required here. At the same time, one stay should be here, one stay sets be here. Here also require the one stay set, another one stay sets. Here also we required one set towards here, one set towards here. So these are the stay sets is required at corner at the end of the poles to avoid any tilting of poles. Okay, so sometimes we can use these sets also. If you are observed in road crossing poles, here if you discuss this one, so we have to provide as per Indian electricity rule, we have to provide the one cradle here. So we have to provide the cradle, guarding should be provided here. So if line falls at any time, it is fallen on the guarding, and the guarding is earthed perfectly. To avoid fall on the persons who are passing through on the road. At this condition, we are going to provide the stay sets here also. We are going to provide the stay sets to both sides. Where unequal forces develop in the pole, that can be avoided with the help of the stay sets. Where it is not possible to provide the stay sets, then we prefer for struts. Okay, so it consists of mainly a stay tightener. So tension in the stay, we can adjust with the help of the screws. Let us see that physically. Stay wires are galvanized steel wire standards that are used for sustaining mechanical load. You can see here this is the one pole here is supported with the help of the stay here. So, this is a strut. Generally, the pole, the line is going in this direction, then we require to provide a stay set this direction. So, this is the one thing you have to remember. So, the force due to the lines, the force due to the stay are equal and neutralize the whatever the forces unequal balances in the pole is neutralized here. Okay. Generally, they are made up of the 6 wires. So, it is made of the 6 galvanized steel wires. So, it generally made up of the 6 wires stranded. So, it is not a solid one, it is a stranded, it is easily to flexible around one wire. So, twisting 7 wires together. A common use for stay wires is in the electricity industry, using the wire to stay power poles and tower structures also. Types of poles used in our distribution system. So, it may be, so here you can see the 5 wire line, here you can see the only 2 wire line phase and neutral, and here strut is supported. Here is the 5 wire line RYB neutral and earthing. Here is the another arrangement, there is a different arrangements, So, these are the based on our requirement, we are going to provide this type of the poles in our distribution system. Now, you can see this is the total stay sets, how the stay set is attached to the one pole, a round pole. What it consists, you can see here, you can see this is the one, this is the one stay sets. It consists of here the pin insulators. So, pin type insulators, you can see these are the pin type insulators. This is the pole cross arm, flat cross arm. This is a clamp, here you can see. This is a stay rod. This is a guy insulator, or we can say the egg insulator. Main aim is of this one is to it electrically isolates the top portion and the bottom portion. And this is the guy wire or stay wire, we can say. There is a splicing, you can see here, to connect the bow, here bow rod. Okay, you can see the stay bow, you can see this is a bow shape, that's why we can say stay bow, and it has a screw arrangements here. We can adjust the screw arrangement and the stay rod, and we can adjust to make the tension inside the stay wire. So, it is the end plates, here you can see, and it is made up of the concrete material, cement concrete stay plate, that is generally made up of the 6 mm thickness, and forged head of stay rod. These are the parts, dear students. This is the pole. So, just you see it, draw the pole arrangement. The guy wire is made to support the pole when overhead conductors run at an angle. The stay wire is attached to the pole with help of clamp at one end and other with another plate, which is in underground. The guy insulator also provided in middle to isolate any electrical leakage current to the lower part of the guy. The upper end of the stay rod is attached to the stay bow base, and a nut is used for tightening purposes. You can see for the clarity, it is a physical stay sets, you can see here. Dear students, you can see the stay bow is used here to tightening the strength. So, guy insulator is this one. Okay, this is the PSCC poles, and this line is moving this direction, and the force, counter force is developed by the stay wire. At the same time, you can say this is a cut point or the DTR, pole mounted DTR. Here you can see the line which is going this direction. To counter purpose, we are going to use the two stay sets this direction. At the same time, LT line feeder is going this direction, so that is countered by this stay set. Okay, so these are the generally you can observe in our electrical fields. Dear students, physically you can see this is a guy insulator or egg insulator. It is mechanically very strong, and this total setting is this direction. So these are the bow and bow rods, the plates which is placed in the inside, and it supports the total mechanical strength of this one. Okay. Now, if where it is not possible to, suppose where it is not possible to place the stay, so the lines are moving this direction, so we have to provide the counter here. If it is not possible, place this area is not available, then we can use the opposite this direction. So another one device that is known as a strut. So instead of if we are removing this one, it will oppose this direction, this moving this direction, counterclock these forces. So let us see, that is also strut. Here you can see the strut. Okay, so physically, so this is a op pole, you can see this is a physical. It will place the pole in steady position. And you can see here, so DTR with help of strut. So this is the same PSCC pole, but is placed in the mechanically tightened. Okay, so these are the stays and struts support them to increase the performance of our HT lines and LT lines. So dear students, don't panic, just you see the figure and draw the figure. So here our aim is to draw as it is. Okay, let us conclude. So what we have seen in this class, we have discussed in this class what is the overhead pole, what are the different parts of overhead poles. For 11 kV pole, what is the main pole, what are how the cross arm is connected, how the pin insulator is placed, and what is the dangerous plate, what is the anti-climbing wire. So how we are going to draw, we have learned, and at the same time we have seen what is the significance of stay, wire, as well as the strut. So dear students, just for knowledge purpose I have given some more details. I think it is no need, but you have to draw by seeing this figure. So what is the stay set, what is the strut, what is the three-phase line. So you have to draw this. It will take them nearly 10 to 15 minutes. So this is the basic idea, dear students. Thank you for listening my class.